Hi. Today we're going to answer the question, how many carbon atoms are in 50 grams of glucose? So this is a stoichiometry question. First thing we need to know is, what is the formula for glucose? We can look that up, but I happen to know it because when I was in college, I spent like 6 hours doing a problem about glucose because I forgot that oxygen is a byproduct of photosynthesis, but that's a whole other story. So I know that the formula for glucose is C6H12O6. Okay, so what do I need to know? I know that I have 50 grams of glucose and I need to switch that into atoms. Okay, so I should figure out what the mass of this glucose is. So I've got 6 times 12.01. I've got 12 times 1.008. These are all things that you guys would look up on the periodic table, but since I'm old, I know them. And then 6 times 16, and add that all up. And let's see, 6 times 12.01 plus 12 times 1.008, good, plus 6 times 16 equals, I got 180.156, and since we're going to be talking about grams, that's going to be a molar mass in grams. So that translates into that, okay? So my next thing is to do Avogadro's relationship. So 1 mole of C6H12O6 equals 180.156 grams C6H12O6, and then I'm going to write this down here, 6.02 times 10 to the 23rd, and then that's going to be molecule C6H12O6. Okay, so there's my relationship. 1 mole of this equals the molar mass, which we found here, equals Avogadro's number. Remember, the 1 mole and Avogadro's number are always the same. So I have grams. So I'm going to start out with 50 grams. Okay? Now, since I have grams, I know I'm going to have this 180 on the bottom of my ratio. So it's going to be 180.156 grams C6H12O6. So my grams will cross off. That'll be easy. And then what I'm going to do is I'm going to put the molecules on top. 6.02 times 10 to the 23rd molecules, because that gives me the exact amount of carbon that I have in there. Okay? But you got to remember that, just like every hamburger has 2 pieces of bread because it's got a top bun and a bottom bun. Not a hot dog, but a hamburger. Hamburger, 2 separate pieces. Hot dog, hinged bun. But what you've got here is in each molecule there's 6 carbons. So I got to do that. So 6 atoms of carbon in 1 molecule C6H12O6. Okay, so you see here, it's actually a 2-step ratio. But what's cool is the molecules cross off, just like the grams did. And what's left is we start out with grams and we end up with atoms of carbon. So I'm going to go ahead and do this math, and you can listen and do the math with me if you're not seeing it. 50 times 6.02 times 10 caret 23 divided by 180.156 times 6. Wow, that worked out really nice. 1 times 10 to the 24th atoms of carbon. Again, I'll try to get better about actually talking more about sig figs, but I just cut it to 3. All right, thanks guys. Talk to you later. Bye.